Yes, yes, that was a nice count. Okay, so are you clear with what is SQL and NoSQL? Can we have some questions on it? Yes, no, guys. Let's have in a chat. Yes. Okay, so let's move forward. So basically, the FOSS file is a podcast series where we discuss about new technologies or open source technologies, and to connect with the like-minded people who are want to give their opinion and ideas on the stage and put them together. So that's why we started this podcast series. And as the success of FOSS file season 1, the language layer, we started the FOSS file season 2, database chronicles, where we have ended successfully two episodes. First is that decoding the databases. Second is episode 2, which is SQL versus NoSQL. And we are now here with the episode 3, in memory databases. So we have our presenter with us, as always, Aratya Pitalwar, and second is Utkarsh Mandape. And we have one special one, the Dosback intern with us, Soham Adhyapak. So let's start today's podcast. So handing over to the presenters. Let's get started.
Just tell me, is everyone able to see my screen? Like, is it visible or okay? Let's switch to this. Just a sec.
And discuss on that. So, what do you think? What is memory? Just a response in text so we can discuss on it.
Hmm. Like, what do we refer to as a memory in our computers?
Yeah, RAM and DRAM, Wi-Fi, great. Just tell me which memory are you using, Jyotira, Aditya. Okay, so okay, so uh, you might be familiar with the terms RAM and ROM, right? Yes or no? Just type yes or no. Yes, exactly. So, what do you think? Which one is faster and which one is slower, RAM or ROM? Utkarsh, what do you say? What do you think? I said, what do you think? Which one is efficient, RAM or ROM?
I think ROM is faster, I guess.
And is there any specific reason for that?
No.
Okay, most of the chat are saying RAM. So what is RAM? What the concept is? Just it is what RAM is. Random access memory. Great. Volatile memory. Correct. RAM consists of cache memory. Exactly. Just a minute, we'll share the screen.
काय झालं?
Yeah. Okay, sorry for the inconvenience. Let's stick to our topic. Okay, so we were discussing RAM and ROM. So we were discussing about RAM and ROM. Some of you were saying RAM is fast, uh, RAM is volatile, RAM consists of cache memory. Exactly. So why? What do you think? RAM is fast, like as Tata said, RAM always. Okay. So is there any specific reason that RAM is faster than ROM or anything? What do you think, Utkarsh?
I think RAM is faster just because how the data is structured in it, right? How the data is stored. Like, uh, let's compare it with SSDs. Like in SSDs, the structure to store data is in three-dimensional format, and in RAM it is in two-dimensional format. And like in RAM, we have byte addressability as well. Oh, by the way, does anyone know what byte addressability is? Hello, just write in chat if you don't know. Okay. So basically, byte addressability is we can target that specific byte in memory to fetch or change. But that is not the case with SSDs and SSDs. And SSDs are basically way faster than SSDs. Uh, give you an example. Just a sec. SSDs took about 50 microseconds to fetch data. Okay, and RAMs takes 17 nanoseconds, which is way more faster than like it's just like comparing a tortoise with a fighter jet with speed somewhere around three times the speed of sound. It's that fast.
Exactly. Great. So basically, whenever we talk about RAM, we talk about computer's main memory, right? Is it?
Yeah,
Exactly. So when we talk about computer's main memory, it is optimal, it is fast. And traditionally, what our disk storage is slow compared to our RAM. So today's topic is all about in-memory database, right? So before starting, we'll just split the terms in-memory and database and understand what each word is, right? So in-memory database is divided by like in-memory and database, right? So in-memory refers to a storage type and where processing of data is stored and operated on computer's main memory, right? That is RAM. rather being stored on traditional disk like hard drives or SSDs. In memory, data is accessible and much faster than data that is stored on the disk. For example, thinking of in-memory database as the Formula F1 cars of the database world, taking your data from 0 to 16 milliseconds. So you can imagine that how fast in-memory databases is. Okay, so we have discussed what is ROM, RAM, and understood the difference between them. So what do you think, Utkarsh? The word in-memory database. What do you think? What the concept is behind it?
Uh, I think as the name suggests, the data is stored in memory, right?
Exactly. But whenever we talk about memory, what do you think? Which memory is used?
Sorry, can you repeat that again? I can't hear you.
Okay. When we talk about memory, what memory we use in in-memory database? We will discuss it later, but just give a rough idea.
Hello, hello. Am I audible? Okay, then I guess you guys are facing network issues or something. Anyways, so what you was talking about?
I was talking about, okay, we were discussing about like what type of memory are we going to use in in-memory database, right? Just give a rough idea about it.
Okay, yeah. So basically, what in-memory database is, we want to like fetch the data as fast as we can, right? Okay. Plus. So basically, we want to fetch the data as fast as we can. And what is faster? What is the most fast medium we have right now? Storing it in RAM, as I have gave the example of uh, like comparison between SSDs and HDDs and RAM. The RAM is the way faster than SSDs, right? So what we'll do is in-memory databases store data in RAM, but RAM is volatile, right? And how the data is persisted and how it is managed and how the consistency of data is managed between the in-memory database and the actual database. That is the thing we are going to see in further slides.
Exactly. So let's move forward and see what other topics we are going to cover. The first is index. After that, we'll see what is in-memory database, different types of in-memory database, and the real-world use.
Okay, so let's see what is it like to fetch data without caching. Okay, so as you can see, there's this hardware load balancer. Basically, load balancers are like traffic dividers for web servers. They divide traffic among the web servers. Okay, so in web server and in database, we want to fetch the data as soon as we can. That is the main motive of us. What happened? For some people, I'm audible. For some people, I'm not. Yeah. Yeah, I also think so. So we'll continue. Okay. Hello. Hello. Now check guys. Am I audible to everyone or not? Yeah. So should we start? Okay. Let's continue. So basically, uh, we want to fetch the data from from the database as fast as we can, right? So what we can do, we can use cache on the servers. Like there are two servers you can see over here. Then what if I placed cache on both of them? I can get the data as fast as I can, right? Let's say the user has set username of him in database, and in local cache the username is stored. Now if the user is requesting for the data, instead of going to database directly, the server will try to find if there is the value present in that cache. Okay, and if the value is present, it will directly send that value to the user. It is way more faster than accessing the database, right? What do you guys think? And there is one more thing. What if uh, the local cache stores the value, but what if the user has changed the value in the database, and the local sorry, the cache present on the server has the previous value? Like if the username of the user was let's say root, and in the local cache the username was also root, but after that, okay, after that the user has changed the username of him, like let's say root 1. Okay, but in server the username is still root. So how will that consistency of the data happen on the server side with the database? And second case, what if one of the server goes down? What will happen to the data that the server was persisting? What do you think? What is the solution for this? We want to fetch the data as soon as we can. So for that, what we are doing, we are using cache on the server. But what if the server goes down? What if, yeah, what if both of the server goes down? What will happen in that case? The data is lost or something?
I think that is the main feature of in-memory database, right? How the data is ensured that it is safe and not lost is the key point for our podcast, right? What do you think?
Yeah, right.
Let's hear the opinion of audience. What do you think, audience?
What do you guys think?
Okay, I'll repeat the question. If the data is stored in cache memory, so as we know, it is volatile. It can be lost, right? So how data is ensured that it is safe and not lost, as we are using in-memory database, right? What do you think the solution is?
The solution is on the screen, guys. Try to see if you can understand and do let us know. Cache he. Yeah. Let me tell you what is the solution. Okay. So okay. So what we are doing in previous like
Hello.
case, we were hello. Yeah, Tushar, you're audible.
Hello, शैलेंद्र.
Yes.
तुमचा आवाजच येत नाही. कट होत आहे. असं काय?
हॅलो, आवाज येतोय? हॅलो.
Hello.
हो येत आहे.
I guess we can continue.
Yeah.
We'll continue.
Okay.
Okay. We'll just continue. We were discussing one question, right? Yes, Utkarsh.
Yeah. So uh sorry. Let's see what is the solution for this. In previous case, we were storing data on the server side, on the server cache, right? And the concern was what if the server goes down, right? And how will we like persist the data, and how will we like maintain the data consistency between the database and the cache? That was our main concern, right? So the solution is, instead of storing the data on server cache, what we'll do is we'll store it in one in-memory database, which is apart from the server. Like you can see this in the diagram. The user is requesting to the server. The server will then see in that in-memory database if the value is present or not. The value, like the values to be cached, will be stored in that in-memory database before. So it will find for that value, and if the value is present, it will directly send it to the client instead of going to the database and fetching that value, uh, right? And if the value is not present, they have mentioned here that if hit if it is found, simply return the data, and if it is not found, then go to the database and fetch the data, right? So that's the thing. But here, uh okay, here the data is present in one global like what we can say, global cache, in the form of global cache. But how will we even maintain data consistency? That question is still there, right? Like, let's take that example once again. The client. The client has one username which is stored in database. Let's say the username is root, and it is also cached. It is also cached in that main cache, like global cache, as root. But what if client goes and changes his username in that database to root one? What will happen? The data in the main cache is still root, right? This request will go through server, and server will find in that cache that okay, the username is present over here, the username is root, so send it to client. But the user name is not root, right? The client has changed that username. So what is the solution for this? What do you guys think? Just tell us in chat what we'll do. Should we rewrite the whole cache or something? Hello. Oh, I'm audible, right? Yeah, yeah. So everyone got the question right, or should I repeat? ओके, तो मैं सिंपल लैंग्वेज में बताता हूँ कि लेट्स से क्लाइंट क्लाइंट ने डेटाबेस में एक वैल्यू स्टोर किया है, जो है उसका यूजर नेम क्या है? रूट। या आई आल्सो थिंक सो। ओके, सो यूजर नेम क्या है? रूट, जो डेटाबेस में स्टोर्ड है, और मेन कैश में भी वही मतलब कैश वैल्यू क्या है? रूट। व्हाट इफ client goes to the database and changes that value to root 1? अभी मेन कैश में वैल्यू क्या है? रूट है, और डेटाबेस में वैल्यू क्या है? रूट 1। अपडेटेड वैल्यू इज रूट 1, और मेन कैश में तो रूट वैल्यू है। तो क्लाइंट की जो रिक्वेस्ट जाएगी थ्रू सर्वर, तो ये तो मेन कैश में फाइंड करेगी ना कि मेन कैश में वैल्यू है विच इज रूट, बट इट इज रॉन्ग, राइट? बिकॉज क्लाइंट हैज जस्ट अपडेटेड द वैल्यू टू रूट 1। सो व्हाट इज द सॉल्यूशन? हमें डेटा, we want the data as fast as we can, so for that we have used cache, but cache में तो wrong value है। Yeah, right, obviously update the cache whenever the data is updated. Nice, that is the solution. So what we'll do, we have to update cache value as well while we are updating the database value. Okay, for that, would it be costly? Yes, it is. What we can do for that is, let's say uh, we are changing multiple values in database, or what we'll do, instead of changing the value on database, we can change the values that are present on cache itself. Like uh, there are multiple values present on cache which we want to change onto the database. We can change those value from cache, combine them, and in one go we can change the value from the database. So इससे क्या होगा कि डेटाबेस को मल्टीपल रिक्वेस्ट भी नहीं जाएगी, और इन वन गो द वैल्यूज विल बी चेंज्ड। हाँ, सो आई वाज सेइंग दैट हम जब डेटाबेस की वैल्यू चेंज कर रहे हैं तभी हमें मेन कैशे की वैल्यू चेंज करनी है, राइट? फॉर दैट वी हैव टू वेज। फर्स्ट इज, first change the value from the cache and then from the database, or change the value from the database then cache. Okay, so the application of these two methods are different. Like let's say uh, one financial services like let's take example of Zerodha. The data is crucial, right? We can't what we can say, we can't take a chance to lose the data. So for that we have to store the data in database. Data मतलब lost होना नहीं चाहिए, right? So for that what we'll do, first we'll store it in database and then we'll store it in main cache. Okay, and you can use the second method in all the cases where the data is not that important. Everyone got this one? Just type yes or no in the chat. Nice. बाकी लोगों का क्या? Hello everyone. What do you think? Vishal, what do you think? Should there be multiple like main caches or something? Hello, are you guys there? Mhm. Yeah, right. I also think so. As Shailendra said, just like online class, they they are answering on YouTube.
Sorry to interrupt you guys. Are you guys, audience, what are you doing? Are you listening or not? Please cue the feedback here. Yes, audience? Anyone?
Okay. I think let's move forward to the next slide. Shailendra.
Okay. So as Utkarsh explained about in-memory databases, right? So let's take one of the example that is Redis. So before starting to Redis, so do you guys know what are the other types of like what are the examples of in-memory database other than Redis? Can someone guess it? As our theme also matches with red theme that is Redis, so it is obvious. Redis is one of the example of in-memory database. But are there any other examples of in-memory database? What do you think? Exactly. Oracle is one of the database that offers in memory option. Okay. So any other examples? What are the rest audience doing? Are they just putting on their podcast and sleeping? So basically, MongoDB is not actually classified into in-memory database. Okay, let's just understand first. Full form of Redis. Can someone tell me the full form of Redis? So after getting the full form, we can have an idea, abstract idea. What do you guys think? What is the full form? Or is there any full form for Redis? Correct. Remote dictionary server. As the name suggests, remote dictionary server. So let's start with, is there any Python developers here in the chat? There should be, right? So what do you guys, it is a question for all, not for Python people, but the dictionary, it is one of the data structures in Python. What is that? Correct. Key value mapping. So as the name suggests, a dictionary, it stores mapping, right, of key and values. So the primary storage, like the how Redis stores the data is in the form of key value pairs. And inside that further we can categorize into sub data types. There are various data types, but the primary what we do is store the values in key value pairs. Okay. Is this thing clear for all? Hello. So this Redis means remote dictionary server, and this project began by Salvatore Sanfilippo. He it was he was the Italian developer, or you can say the project of Redis was started by him, and primarily it stores the data in key value format, right? So the again the question, how do we ensure that the data is consistent, right? So there are various architectures that we are going to cover that are basically two architecture. First is master slave architecture and the second is cluster architecture. Okay. So we'll move with the master slave architecture.
Hello. So as you can see, this is the report of Stack Overflow Developer Survey 2023 of the most popular databases. Okay, you can see the first number is Postgres and so on and so on. The Redis comes at sixth with 20.41%. Okay, in the world. That's how popular the Redis is right now. And you can also see at the bottom there is Cassandra and Supabase. By the way, do you guys know about Supabase? Does anyone know? It is currently the most popular open source alternative of Firebase. No? Okay. Basically, it is the most popular alternative to Firebase right now. Superbase, and it is open source. Yeah. Okay. Let's go to the next slide, guys.
Okay. So we'll understand what is this actually the architecture of master slave architecture. Okay. So this Redis server can be run in two modes. The first mode is master mode or Redis master. Okay. And the second is slave mode, that is Redis slave or Redis replica. So we can configure which mode to write and read from. Okay. So it is recommended that server writes through the Redis master and reads through Redis sleeves to achieve the consistency. Okay. So by default, Redis sleeves are configured to read only to avoid the data inconsistency and have the same data across the sleeves. Okay. Now you might think, what if one of the masters goes down or one of the slaves goes down? What will happen? What do you think? First, we'll understand what if the Redis master goes down. What do you think, guys? What will happen if one of the master goes down? Is the question clear to everyone? Please try to answer in chat. Yes, slave will become master. That is one of the solution. So we'll also discuss there are one or two solutions that we'll discuss and which is the efficient one. We'll also discuss on that. Let's hear which are the other possibilities. So what our motto is to have data consistency. So what we'll do, we write through Redis master and we read through Redis slaves. Okay. And what do you guys think? What are the other options? What if the Redis master goes down? One of the solution was provided that slave will become master. Is there any other option that new master can be added? Okay, assign a new master. Okay, so there are two possible solutions. We can have one new master, or the second one is we'll just pick one of the sleeves and convert it into a master. Okay, that is one of the solutions. So let's try to brainstorm on the first solution. We'll add a new master. Adding a new master can be somewhat difficult, like in cost, in terms of cost, because adding a new master, it will be completely empty, right? What do you think? Adding a new master is less efficient, or making one of the slaves as master will be efficient? By adding a new master, so we need to replicate the data, right? So it is like not as efficient as the second one. So we'll brainstorm on the second one. What this second solution provides is making one of the slaves as the master node, right? The Redis master, making it Redis master. So what will happen? Whenever a client writes through or makes operation on the Redis master, it is replicated into its multiple slaves. And in case when the Redis master is down or due to some failure it is down, so we can pick any of the slaves. It will have all the slaves will have the same data or the same replication. So one of the slaves will get selected and he will be converted into Redis master. And once again, our database is ready to use. That is the major, or you can say the key point of this master slave architecture. Okay, making an existing Redis slave as a new master. That is one of the good. Now let's understand, what if the Redis slave goes down? What do you think? Is there any problem if one of the Redis slaves goes down? Just think on it and answer in the chat. Exactly. Nope, as we have the same data in others. Exactly. So what this Redis slaves do, they just perform the read operations requested, right? So since all Redis slaves are having latest set of data, or you can say the replication from Redis master, if one of the Redis slaves goes down, other Redis slaves will serve the read request. So that will not have much impact on this architecture, right? So our main target is Redis master. We need to provide some backup to the Redis master, and which can be done using Redis slaves. If Redis master goes down, we'll just replicate the Redis slave into the Redis master. That is the optimum solution. Now, still the question remains, like how Redis ensures the data durability, as all the data is stored in computer's main memory. There can be possibilities, right? If suddenly the computer restarts or the system crashes, there is a high possibility that our data would just disappear. So Redis provides one of the mechanisms that is actually a very great idea. So we'll also discuss on that. So before hearing that solution, let us understand, is there any fault in this master slave architecture? What do you guys think? Costly maybe is making the same repetitions, converting from Redis slave to Redis master. And also there is a dependency issue. Okay. So for that, we have another architecture, that is cluster architecture. Okay. Utkarsh, what do you think this cluster architecture is?
I guess it reduces, or like in the previous architecture, we have dependency on that master node, right? What if the master node itself goes down, which is managing all the things, right?
Yes,
So
exactly.
to tackle, yeah, so to tackle that, we have cluster architecture in which there are multiple clusters, multiple master nodes, and multiple slaves associated with them. Right. That is what the solution for that is.
Yes. And in this way, we can have data consistency as well, and there is no much dependency on a single master, right?
Yeah, right. And by the way, uh, do you guys know how the data durability is achieved in Redis? Like, what if uh, there was data in one Redis instance, and that instance goes down? Okay, so how will we recover that data? Hmm. Let me tell you what Redis does. Basically, Redis has two functionalities for that. First is snapshot, and the second one is AOF, which is append only file. Okay, Let me tell you about what is uh, append only file. Hello.
Okay, so the solutions provided by Utkarsh was AOP, right? Append only file, and the other one was snapshotting. So before brainstorming on that, let us understand like how the actually workflow is in memory database. Okay, so here you can see there is in memory database, and all the operations are made to the main memory, and there is a disk, right? The transaction logs. So the very first approach is snapshotting. So to ensure periodic snapshots. Now, what basically snapshots means, what we'll do, we'll make all the operations in the main memory, and after every interval, we'll just replicate one data set into the disk storage so that we can save all the datas on our disk for permanent or for the future use. That is one of the mechanism of snapshotting. So what this snapshotting does, it supports periodic snapshots, and this provide they capture, what they do is they capture the data set's state at a particular time and save that data set into a disk. So what we are going to do is we'll just perform all the operations on the main memory, and after an interval of time, or you can say a specific time, we can set it manually, and after that time we'll just take a copy of all the data that is available on the main memory, and we'll just store it on the disk. So in this way, the data consistency can also be achieved. And if the system crashes in the failure, or we restart the program, or we restart the system, there is no issue of data, like what we say. The data will not disappear. We can have one-time operation on the disk storage, right? One time we can just fetch the data and we can just continue to save in the main memory, but repeating that same number of tasks, right, making the input output operations on disk is costly and it is much slow, right? So what we do, we just make one copy at a specific interval and save that on the disk. And now the second option, that is append only file. So what this concept is, Redis offers an append only file persistence mode where every write operation is logged into an append only file on disk. This logs contains a record of all write operations, allowing you to replay them as a to rebuild the database. So it maintains an append only file, and in that all the operations are recorded. And in case if you want to rebuild our database, you can just use that file and rebuild our database. Simple as that. So what do you think? Snapshotting and append only file functions are helpful for Redis, or is it costly? Exactly. Repeat only once. And here the basic question, as we discussed in the very starting, what is the type of, like, how is the data format for Redis? Is it in which category this Redis comes in? Like, is it SQL database or NoSQL? What do you guys think? NoSQL as key values. Exactly correct. So it's one of the example of NoSQL database, right? It stores in, as the name suggests, dictionary, right? Key value mapping. So after this, that how the flow is actually, what do you guys think? Will the solution that we've provided, that is snapshotting and append only file, will solve the problem of consistency, or there should be some mechanisms again? Hello, am I audible? Hello, hello. Okay, great. So my question was, is this mechanism enough to avoid the problem of data inconsistency? What the others think? It's not a session of just a lecture. It is a two-way communication. The You might have some information that we might not know. So just try out all those answers in the chat so that we both have the same good knowledge, right? There are 14 in the audience and just one or two are replying. What do you guys think? What are the others doing? Like the question. Is this snapshotting and append only file the only way possible to save the data? Okay, till then, Utkarsh, tell me, are you satisfied with these two solutions, or there Redis should have some more complexities or functionalities to save the state?
I think these two functionalities are enough, right? Because by using both at once, we can, do data consistency and do all kind of stuff.
Exactly. And as this using in memory, what do you guys think? What will be its application where this Redis is going to be used? Okay, by the way, I have one question for everyone. Why why this Redis is mainly focusing on the response time, right? The motto of Redis is to have less, the response time should be minimum, right? It should, whenever a request is made, it should be fetched in very few seconds, like not even seconds, nanoseconds or something like that. So what do you think? Why this was a major focus for Redis? Hello, I guess I'll have just put on their this podcast and yeah, roaming here and there, I guess so.
Hmm. Just like online classes.
Yes, nostalgia. So is my question clear for everyone? I guess one of two are typing, so we'll just wait for the response and we'll just continue the discussion. Okay. We will continue. Now, as we've mentioned, right, the major focus is on the response time. So where this response time is actually used, one of the application is gaming, right? As there are various online games, what we expect? We expect low latency. So what do you guys think? What is low latency? What the term suggests latency? If we consider any of the games such as Valorant or any other CSGO, what we expect is there should be no lag. There should be fast response, right? So this is one of the application field where we can use Redis, right? To have the data previously in the main memory. And in online games, the response time should be very minimal. Once we hit a headshot and just for the case of milliseconds, it does not connect. What we do, we blame the game. We blame the game that it's very slow, the latency is very not too good. So what the major objective is, it should have low latency, as low as possible, to avoid lags, to avoid delay. Right? That is one of the applications, and also for location-based service. Okay. So guys, what do you think that this is being used in services? Is there any specific reason?
Uh, Sorry, can you please repeat your question?
Like why location-based services is used by Redis? Like why Redis is using that location-based services? One of the application mentioned was location-based services.
Okay. So basically, the whole thing is we want the data as fast as we can, right? And in location-based services, uh, the changing of latitude and longitude happen in an instant, right? And we can't just perform that and by using any other thing because that will increase the time taken by the response. Sorry, the request. So we want to reduce the overall time taken by the request. For that, we use in-memory databases like Redis, and that's
Exactly.
why I think the location-based services use that. And also, apart from gaming, location-based services, notifications and alerts, it is also being used in chat applications as well. Redis does provide features like publish and subscribe for that. Yeah, basically the applications are there are a lot of applications of Redis than we have mentioned over here.
Yes, exactly. And the chat application that you mentioned is also like the time is very crucial factor right there. We text someone and we should there what we expect is there should be no delay. As soon as the request is sent, we should at least get the response back. So what for that purpose, the Redis is widely used and also for location-based services. The live tracking, right? It should automatically reflect. It is of no use, right? I'm just putting my live location on and it is reflecting after 2 to 3 minutes. So at that time, the user will not have any he will not the user will not have any what you can say that uh, interest in using that application. So what does Redis do? They provide a way faster request to handle the request. It provides a mechanism. So this was about the Redis. So the first question was asked, any other examples of in-memory database? We'll also be covering one of the database. So just before starting that, let's just check, is there any other examples? If you have any, just put in the chat so that we can discuss on that.
Yeah, like any of the in-memory databases that you guys know, or you can also search on Google. Let us know what are the data in-memory databases that we haven't heard of. other than Redis? Apache, okay. By the way, uh, Pranav, Yash, Harshvardhan, and Vishal, do you guys know any other databases other than Redis? Like, or any other databases that provides similar functionalities like Redis? So one of it is Memcached, HSQLDB, nice. So you can search it on Google and tell us in chat. Uh, so we'll see what is Memcached. Okay. So basically, Memcached is in-memory database, the most simple in-memory database. Okay. Uh, what we can say, it is built just for its simplicity. Like the main purpose of building this Memcache database was its simplicity. And by the way, it is built by Brad Fitzpatrick or something in 2003, and it got most popular because of Facebook, because Facebook was using it in their caching process. So let's first see what Memcache does, how it works, and then we'll see the Facebook part. And there is one more interesting thing the Memcache is used in, uh, like current world. Firstly, what Memcache does. So basically, it is simple. It doesn't provide that much features like Redis, like what we have seen. For example, clustering. In clustering, there are multiple instances of Redis like master node, slave node. But in Memcached, uh, even if we create multiple servers, they are like each of the server is not aware about the other one. They are independent servers. We can create clusters, but they are not like aware about the other. That's the thing. And about its memory storage, like how it stores. The thing is, we have limited memory, right? And the data size that we are putting into that will not be consistent always. Like in one time, we have like few bytes of memory to store. In other like request, we have memory like the data to store is huge, can be huge. So the data size is inconsistent, right? So uh, as being the simple in-memory database, it was storing the data in inconsistent manner. Like wherever there is a space, it was saving that data onto that, and there was some space remaining in between those memory spaces or memory locations. To tackle that, what Memcache does, basically इन्होंने किया क्या कि they provided pages, like they have assigned 1 MB pages for every data. Also, and by the way, the 1 MB pages are also divided into smaller chunks. So that's how they solve that memory gap issue of that. And everything is stored in string. The memory cache issue is resolved. But as I've mentioned, that the memory, like the what I can say, the present memory on the current system is limited. We don't have unlimited amount of memory to store data onto like the caching, right? We have to remove it as well. But what should be the criteria to remove that? Basically, memcache use LRU for that. LRU is basically least recently used. What it will do, it has stored some data and it will track what is the data that is being used most amount of time, and it will move that data or key value pair to the top, and the data which is not being used most of the time, it will remove it. That is the most simple explanation for that. That is how it manages the whole memory kind of thing. And about connections as well, uh, the thing is being simple. Just a sec. Okay. Yeah. Apart from being simple, there are some disadvantages of it as well. Like, uh, if multiple instances are there that are connected to that memcached, it is using thread for each and every instance. Like, if two requests are like two requests are there to connect to memcached, okay, so it will create thread for each of them. As some of you might know that threads are limited in kernel side. There are user level and kernel level threads, but the kernel level threads are limited. So it is not a good use of kernel level threads in this case. Read and write operations are there as well, but these are all done using hash tables. Like, the keys are stored in hash tables, and the thing is, as some of you might know, in hash table as well, we perform some hashing function, right? After performing some hashing function, we get one location to store the key. But in this case, let's say at position 2, we already have one key, or we already have some value stored in that hash table. After performing hash function for another data, we have got that same location. Just consider. Then what it will do is it will store that key value after the previous key value. Okay. So let's take one scenario where there are, let's say, 10 keys stored in that one location itself, and we want only one key to be found. Even if we want only one key, we have to traverse the whole thing, whole 10 keys to find the right key. That is one more disadvantage of it. It basically uses UDP and TCP as well for that communication purpose. And about UDP, I will tell one story about what is currently happening related to Memcache. But yeah, let's see what Facebook does. Like Facebook, sorry, what Facebook did by using Memcache. What they did is they reduced the amount of requests that were going to their servers by using Memcache. That was the thing we were discussing in second or third slide, I guess, about what is the use of in-memory databases. That is exactly what they did. But they have to they have to do some changes in Linux kernel that they were using at that time. And even after using 28 terabytes of RAM, I guess the server were crashing because the meme cache were not optimized at that level. They had to make changes in meme cache itself. Okay, so that's how Facebook used it. Does anyone have any question? Big disadvantage, yeah, right. You can think of it. Even after having 28 terabytes of RAM, 28 terabytes of memory, the server was crashing. And not right now, by the way. Before, I guess, 8 or 10 years. Yeah. So just a second. Shailendra, hello, are you there? Hello. Can you please uh, close that presentation, because I have one document to show them. I will share my
Yes.
screen right now. Okay. Just tell me in the chat, is everyone able to see my screen? Is my screen visible? Yeah. Okay. So अभी देखते हैं कि मीम कैश का यूज कहाँ पे हो रहा है currently, which is the most funny part. Okay. So here I have found one Cloudflare article about the meme cache DDoS attack. So what is happening is what DDoS does, if we request for, let's say, if we send a request to memcache server with, let's say, the request size is less, even after the request size being less, it sends the response in pretty large format. uh, they have mentioned here as well. Yeah. So what attacker were doing is, they were sending request to that memcache server, okay, with the IP of target. तो हम क्या कर रहे थे, लेट्स से memcache सर्वर है, उस पे टारगेट, मतलब IP spoofing उसको कहते हैं, like pretending to be that server. Like for example, there is one memcache server and I am sending one request pretending that I am from Google server by doing IP spoofing. Okay, so what memcache server was doing was, uh, in response of that request, it were sending a big request. Like the request size was so big, that it was around, just a second. Yeah, 51,200 times bigger than what was the request size. Okay, that's how big the response size was. So by doing that, they were performing DDoS attack on servers. That's how it was being used. And to tackle that, they said you have to disable UDP. Basically, it uses TCP and UDP both, and to disable IP spoofing as well. That's how the meme cache is being used right now. Cache poisoning. Uh, I don't know about that. By the way, what a like creative way of using in-memory database, right? Yeah. So basically, this was about it, guys, about in-memory databases. Let's see if anyone have any doubt about or related what we have just discussed.
Yes, audience, any doubt regarding in-memory databases? Our presenter is well prepared for your questions. You can ask any questions. Yes, presenter, yes, you have a doubt. So if there are any better alternatives to Redis or just it Redis that can do work, what do you say on that?
Okay, there are two possibilities, right? For Redis as a in-memory database and Redis as a NoSQL database, right? So the question can be tackled in two subparts. So which one we want to answer is not getting right. Redis as a in-memory database alternative or Redis as a NoSQL.
Hello. Yeah. So in case of in memory, I guess I've just covered memcache, right? And there is one video on YouTube that were comparing memcached and Redis, like their performance. Basically, what they did is in one server they ran Redis, in one server they have set up memcached, in one there is no caching, and there is one mechanism to monitor three of these servers, like how they perform and things. So memcached nearly performed at, like, what we can say, the difference between the performance of Redis and memcache were not that big, so we can consider memcache as well. But the finally the Redis won.
Yes, exactly. What I think is Redis is way much good. Okay, one of them requested to join the speaker, right? I think Garatya.
Any more doubts, anyone?
Okay, so Aratya, am I audible? Hello. Okay, June, for everyone, the question is for everyone. What do you guys think? Which database to be used? Which is the most efficient one? What do you guys think, Utkarsh and Aratya? What should be used whenever we develop any application? Yeah, it actually depends. What are the type of application would be? What are the constraints? Exactly. As Aradhya present, I had one question, right? From the first episode, like we were comparing SQL and NoSQL. We saw types of database and now this in-memory database. So I wanted to know the experience of like Aradhya, like from the three episodes. What do you think? Which is the most optimum database in general case? Also, everyone can answer that question. Not only it is not specific for him.
I guess most of the people are going to answer MongoDB since they haven't explored other databases, I guess. depends on the requirement. Yeah, right. Hmm.
Next one, if you give a scenario, then I think they can answer very well. So, guys, have you any questions, or we will go to the conclusion part of the podcast? So, I think the chat don't have any questions. So, let's get to the conclusion of the podcast. So, thank you, presenters, for being here, for sharing your opinion on in-memory databases. I think there is one more question. Are all in-memory database NoSQL? Presenters.
Okay, as far as I know, one some of the database they are no SQL, right? For the efficient access and for storing in the RAM. That's what I think. What do you think, Utkarsh?
Yeah, right. I agree with you. The thing is, uh, NoSQL, like, it provides what we can say, the advantage of structuring the data by ourselves, right? So, so from that case, it is an advantage. That's why most of the in-memory databases are no, and most of them are key in key value pairs. Though they provide some features like, for example, Redis provides features like res sorting, not res, list sorting lists, and uh, it though it stores it in strings, but it does provide that features.
Yes, and also it is not restricted to one database, one data type. So it can have multiple data types, but the primary storage for the Redis is just key value pairs, right? That is what I
Yeah,
think.
right.
So any other questions?
So, I think your doubt is now cleared. So let's get to the conclusion. So in the podcast from the starting, we learned about what is in-memory databases. What are the different types of in-memory databases? One of them is Redis, remote dictionary server, and second is meme cache. And we also get to know about what is the master-slave architecture and what is the cluster architecture and how it is work. What are the applications of the in-memory databases? So these are the topics that we have covered in the podcast today. And thank you, Soham and Utkarsh, for your valuable time. And just a short in क्या बोलते हो उसको? And just a short notice. After this episode, we are going to declare a break of 1 week due to our exams, and we will be continuing the same season on 30th September, and it will going to be the finale. Please join on 30th September to get the interesting ideas of databases and for the finale also. Thank you so much for being here, giving your time. Thank you.